This is 2014 sample paper, just a selection of a couple of questions. So, 1 second, there we go. That will load up now. Okay guys, so show the following. Oh no, you didn't. The first one's done like this, okay? There's a couple of rules, excuse me. There's a couple of rules in the papers, alright? So one rule is this: x, a to the power of x by a multiplied by a to the power of y is a to the power of x plus y. If you don't know what that means, something like this: 3 to the power of 2 multiplied by 3 to the power of 4 is 3 to the power of 6. You add the powers. There's another second rule: a to the power of x to the power of y equals axy. Another example being, I'm going to do something that looks very similar to the one above. 3 squared to the power of 4 is 3 to the power of 8. Another rule is anytime you see a square root sign, it means that number to the power of a half. So, and then finally the division rule: 3 to the power of 4 divided by 3 to the power of 2 is 3 to the power of 2. It's 4 minus 2. If that was 7 over 2, what would the answer be? 5. Okay, these are the bargain basement power rules. They're on page 20 or 21 of your book, your maths table, so you can figure that out. Right, so we're going to start off with this. We're going to start off with the a root a. A root a is a to the power of 1, and root a is the same thing as a to the power of a half. You're then going to use the multiplication rule, add them together, and you get a to the power of 3 over 2. I've only done that part there. There's still a power to 3 on the outside, and there's a to the power of 4 on the bottom. The next thing I'm going to do is I'm going to do the multiplication rule. The multiplication rule is this one here that I'm going to highlight in the box. So what can I do with the top part then? See the way I multiplied the 2 by the 4 to get 3 to the power of 8. What can I do with the 3 over 2 and the 3? Multiply it out, and if you put in the calculator 3 multiplied by 3 over 2, I'd advise you to use the calculator for every fraction you're going to do. 9 over 2, a to the power of 9 over 2 over a4. Now we're on the division rule. What's the division rule, guys? Take them away from each other, and when you take them away from each other, what happens? What's 9 over 2 minus 4? You can just put in a calculator and find out. You're going to get a to the power of a half. And what did we say a to the power of a half was again? And that's what it asked me to verify, that it was root a, and you're done. The next one is using these power rules from earlier again. Now, see the way we have two different base numbers? See the way it's 49 and 7. I found a new trick, by the way. I know it's really obvious, but if you put 49 in the calculator, see this fact button there? See fact? And see the way it's in yellow? If you press shift fact, it breaks it down into its prime numbers for you. Okay, so you can see that it's going to be 7 squared x equals 7, 2 plus x. Now, does everybody understand it's still the same question? The only thing I did was I changed 49 into 7 squared. What can we do after this then? The multiplication rule. Remember I said a3 to the power of 4 is a 12. You multiply them, so multiply 2 by x. Alright, and now the base numbers are the same, so what can I do with the 7s? Get rid of them, so 2x equals 2 plus x, and then bring the x over to the other side. You're going to get 2x minus 1x equals 2, x equals 2. Okay, if you haven't done them in a while, they're difficult. If you've done them recently enough, they're not so bad. Alright, solve this simultaneous equation. Now, guys, can anybody tell me, simultaneous equations are usually something like this. Okay, that's one type of simultaneous equation. That's the type of simultaneous equation where you multiply the bottom one by 2, and then you get 2y minus 2y, and they cancel. Isn't that right? There's a second type of simultaneous equation, and we would have done them recently enough. So this is one example. This is example A. The one I'm going to show you below is example B. And you got to tell me what the main difference is between A and B. What's the difference? it's a quadratic. If it has x squared in it, it's a quadratic, and it can't be done by the usual means. You know, way on the first one you go, multiply the bottom one by 2, and you get 3x plus 2y equals 10. You'll get 2x minus 2y equals 15, and then you add directly downwards to get 5x equals 25. You can't do type B like that. So do we have a type A or a type B in this question? It's a type B, isn't it? And because it's a type B, what we're going to say is this. For type B equations, you go to your linear and you get one letter on its own. Which letter would you suggest I get on its own? S. Minus S equals 10 minus 2r. Multiply both sides by minus 1. S equals 2r minus 10. If I got r on its own, I would have ended up with a fraction, and that makes the whole process a lot more difficult. At ordinary level, you'll always have a choice to avoid the fraction. I suggest you always avoid the fraction. Okay? What can anybody suggest I do next? Sub in. So anywhere I see s, I'm going to replace it with what? 2r minus 10, and that's 2r minus 10 squared. Okay? So you're going to get a 2r squared minus 10r, and then you're going to, I've multiplied this out for you in your notes anyway, so it's going to be 4r squared minus 40r plus 100. If you're looking for the longer version of that, check your notes. I did it out completely. Now, what's next, guys? What type of equation do you think is going to happen now? We're going to multiply them by the minus 1. And anybody know what to do next? What type of equation is this? Huh? It will be a quadratic very soon. Any suggestions on what to do with that? Multiply by minus 1, and then divide by 2. Divide by 2, we get r squared minus 15r plus 56 equals 0. What's the reference number, guys, on this, Dennis? Reference number. What is it? 56. What two numbers multiply to give you 56? Yeah, 7 and 8 will do you. It's a plus reference number. If it's a plus reference number, that means you can have two pluses or two minuses. We're going to go for two minuses. Why did I do that? Minus 15 in the middle. And then once that's complete, you're going to get r equals 7, r equals 8. Go back to the start and you realize, well, I also have to find out what s is. S equals 2r minus 10. This means s equals 2 times whatever r is minus 10. Now, r has two different values, so what does that mean I should do? I should try them both out and see what happens. So when r equals 7, what's the answer? 15 minus 10, or sorry, 14 minus 10, which is 4. And when r equals 8, 16 minus 10, which is 6. And there's your two answers. If you're asked to represent this on a graph or something like that, you can see one of them will be a curve, the other one will be a straight line. The linear one's a straight line, and there'll be 2 points where they intersect each other. So if you ever asked for the coordinates, you'd pair off the x and y. It had to be x and y if they're asking for coordinates, though. Yeah. Shh. Okay, guys. So we have this here, okay? Now what you're gonna do, guys, for really easy marks, all you have to do is just go to your calculator. Am I recording this? Oh yes, I am. Go to your calculator, and all you have to do is just press mode, table function, and then do 2 to the power of x. So 2, press the power button, press x, and then go from 0. Sorry, equals. Now, what should my start be? What's my lowest x value? 0. What's my end? 3. What's my step? It shouldn't be 1 because I need to find out 0.5 values as well. So I'm going to press 0.5, and then, long and behold, I have all these numbers here. Will somebody call them out for me? Just during the notes. So what goes here? 1 after here. 4 and 4 after that. 2 after that. 2.828 after that. 4 after that. 5.657, yeah, after that. 8, and then repeat procedure for g of x. So repeat procedure for the lower one. So you just say 9x minus 3x squared minus 1. Same procedure, and you get new numbers. So what are those new numbers? Minus 1. What else? Yeah, 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 yeah. 2.75, and finally minus 1. Okay, guys. You draw that out. Having graphed this out, we have two functions. The green function refers to the power of x, so that's your green function. Your black line refers to your quadratic equation, which is n-shaped. Why is it n-shaped again? Negative x squared results in an n-shaped graph. Positive x squared will result in a u-shaped graph. Okay, so you have this graph here, and now you're asked to answer some questions on it. So what I'll do next is I'll just bring it to the questions we're being asked. Use your values to estimate the values of x for which to the power of x equals plus 3x squared minus 9x plus 1 equals 0. Now, that is a very random equation. You've never solved anything like that before. But the hint is it's asking you to use your graphs. So the two graphs you drew must have something to do with it. So what I'm going to do is I knew I drew to the power of x. So what my decision was is I'm going to isolate to the power of x, and I bring everything else over the other side. So I'm going to get to the power of x equals, was it 9x minus 3x squared minus 1. What was the graph of to the power of x again? That was the green one, wasn't it? So that was f of x. And what was the other one? G of x. It's basically asked me the values of x for which f of x equals g of x. When are they equal to each other? When are the two curves equal to each other? So what values would you say they are? We're going to scroll down here. Not 0.5. Say halfway between 0 and 0.5. X equals 0.25, and then the other one 2.2. You can see that done in the notes as well. Okay. Alright, guys. So we don't really need those two answers there now. Okay. Then next one is let k be a random number such that to the power of k equals 6. Use your graphs or otherwise estimate a value of k. Now, the problem with this one is, did we draw anything similar to the power of k? Was there anything similar to that? We drew to the power of x, didn't we? And when was to the power of x equals 0? So when does the green line equal 6 is what we're asking. To the power of x is roughly the same as to the power of k. To the power of x can be represented as f of x. When does f of x equal 6? Anybody tell me? So it's 6 up here, isn't it? And you go across and you go straight down, and we're saying around 2.6, is it? So x equals 2.6. If our answer is correct, 2 to the power of 2.6 should be a number that's very close to 6. Let's find out. 2 to the power of 2.6, 6.06. Close enough. Means our answer is just slightly above what we're looking for, but roughly right. Is that right? The next thing I want you to know is in differentiation, okay? If I have any function like this, just say something like this, when I differentiate it, I get a formula for the slope. So, does anybody remember how to differentiate? Bring the 3 to the front. What happens then? Take 1 away from the power, and you get 3x squared. Bring the 2 to the front. Take 1 away from the power. It's 2x1 or 2x. Any number when you differentiate it turns to 0. That is the formula for your slope. Everybody got that? Now, do you see the way a cubic function Yeah, the cubic function is the graph that's here. So that's like a random cubic function. Okay? When you differentiate it, you get a formula for the slope. Now, what if I was to draw that graph? Just this graph here. What type of shape would that be? N shape or U shape? U-shaped. Okay? So this would be a U-shaped function. Maybe a bit like A or a bit like C. One or the other. Now what this means is this. For different x values, so do you see x equals 1, x equals 2, x equals 3, x equals 4, x equals 5? Now, x equals 1 has a slope like this. X equals 2 has a flatter slope. X equals 4 has a similar slope. And then x equals 5 has the steepest slope. Do you see the way the slope keeps changing depending on what your x value is? Yeah? Now, here's the key thing. Alright? A slope can be negative or positive. So as an example, if I was to draw it like this, if I was to draw a new function like this, do you see the way it's positive at 1? See the way the slope is positive at 1, yeah? So this is x equals 1. This results in a slope that's above the x-axis, a positive slope answer. Okay? And you see x equals 2? Once again, it's on its way up, it's a positive slope. But when you get to x equals 3, what happens? It's a negative slope. So if I was to plot x equals 3 here, you can see the way the slope is below the axis. Sorry, see the way the y value is below the axis. This refers to a negative slope. Okay, because this here is the graph of the slope, so it refers to a negative slope. And then you'll only go positive again. When does your slope turn back positive again? It's negative, it's negative, it's negative. And then what happens here at x equals 5? It turns back off. So this here, when your slope equals 0, that means your y value is 0 for this graph here. So that means your x value will be 5 here. And then any value above 5, your slope is positive again. Alright? So, long story short, in this question here, you'll see that the slope is always going in which direction? Slope is always positive. Yeah? This means that when you draw a sketch of your slope, these are all sketches of the slope. When you draw a sketch of the slope, because the first derivative is the slope, so these are all sketches of the first derivative, what happens is you're looking for a slope that's always positive. Y value is negative, y value is negative, the y value is always negative. This would refer to a graph that just keeps going downwards. That's what that refers to. Okay? What does graph D refer to? So at x equals -1, it's negative, so it's on its way down. Okay? And then it turns positive at, let's say, x equals 2. So it turns around at x equals 2, and then it starts going. It's positive, it's positive, it's positive. And then at x equals 4, for example, what would happen then? It turns back to be negative. So that would refer to a graph that looks like that. Our graph, however, is always positive. In which graph is the y value always positive? C. Because see the way it never goes below the x-axis means it's never negative. Okay? So yeah. All right. So in graph C, no. See that's the x value. So the y value is the slope. When you sketch the first derivative is the slope, and the y value is the slope. Okay. So what happens here would be basically what happens here, guys, is that the y value is always positive. So the y value never becomes negative, therefore the slope never becomes negative. So as I said, if you have a curve like this, something like that, if I differentiate it, the slope is the derivative. So you get 3x squared plus 2x. If I draw this graph, which is a U-shaped function, the y value is the slope value. So for instance, in this graph here, if I set the point 5, 8, do you know what that means in this graph? When x equals 5, the slope is 8. That's what the points mean on these graphs. Okay? but it has nothing. It doesn't tell you anything about the original graph other than what is the slope at that point. So, for example, at x equals 5, remember I said that's the 0.58 on the second graph. When x equals 5 on this one, you're going to have a slope of positive 8. That's how they relate to each other. Alright, in question 9, guys, what we have is what type of, if I was to draw this out without even using the calculator or anything, what shape do I know automatically it is? It's an n-shaped curve. How do I know it's an n-shaped curve? Minus n squared. So it's going to be an n-shaped curve, okay? Now what it says is, a farmer has grown winter wheat. The amount of wheat he'll get per hectare depends on, amongst other things, the amount of nitrogen fertilizer he uses. For his particular farm, the amount of wheat depends on the nitrogen in the following way. So what I can do here is, I can match this equation using my own language. F of x is going to be y. And instead of using n, what am I going to use? I'm going to use x. Okay? X squared, okay? I'm going to start at 0 because you have to use something. Okay, so I'm going to start off at 0. Now see the way he says using 100 kilograms? Yeah? That means I should go up in tens. So I'm going to stop at 200 and go up in tens. The only reason I knew to go up in tens was because of what? The 100 kilograms at the start. If I only went from 1 to 10, I wouldn't have enough information. So I'm going to show you what this means here. This graph means if you use no fertilizer, you get 7,000 kilograms of wheat. If you use 50 kilograms of fertilizer, how much wheat will you get? 8,350. Does it keep going up? Does it? Keeps going up. Keeps going up. And do we reach a maximum point? Any point? Oh, there it is. There. 160. You can see it right away, can't you? 160 is the maximum. So if I was to draw this point here, this point would be 160.9560. Even just by doing that, I can identify where my maximum yield is, because it's an n-shaped curve. You're going to use 160 grams of fertilizer to produce 9,560 kilograms of crop. Right? Now you have to show workings. Y equals 7,000. You're going to find out how much you need for 100 kilograms. So how much do you get for 100 kilograms? Anybody? You put 100 in here and 100 squared, right? And you can go back to your table function and just go up to 100. 9,200 kilograms. Okay? Or you could just do it normally in a calculator. Find the amount of nitrogen that he must use in order to maximize the amount of wheat produced. 160 and 9,560. Now there is a differentiable way of doing this. You should try. This is your reserve plan. You see, drawing the graph and just saying that's the peak. That's your reserve plan if you forget everything else. This is plan A I'm doing here. Plan A is this. Turning points. You can have either a maximum turning point when it's an n-shaped function, or you can have a minimum turning point when it's a U-shaped function, yeah? Now the other thing is, what's your slope at your maximum and your minimum? The slope is 0. So the first derivative is equal to what? The first derivative is the slope, and therefore the slope is 0. So differentiate it and put it equal to 0. When you differentiate 7,000, what you get? You're differentiating y using the letter n, dy dn. What happens when you differentiate 7,000? 0. What happens when you differentiate 32n? If it's 32n, 50n, the n just disappears and it becomes 32. And finally the last one, n squared. What do you do with the 2? Multiply it by the minus 0.1 to become 0.2. Take 1 away from the power, n. Now that has to equal 0. 32 minus 0.2n equals 0. 32 equals 0.2n. 0.2n equals 32. Divided by 0.2, and what do we get? I guarantee it's 160. It's 160 kilograms. We did 160 kilograms to find that. If you're finding this really tough, and you've always found it tough, option B is to draw the graph or have a quick sketch in the graph in mind. Keep an eye on the numbers to the right and figure out when does it reach its biggest value and when does it start coming down again. That can work on occasion. What is the maximum possible amount of wheat produced per hectare? We got the answer right, didn't we? 950. Now, how would you do that without the table function? You'd insert your 160 back into this formula here. So it's 7,000 minus 32 times whatever the number is minus 0.1 times whatever the number is squared. We used 160 both times, and that produced a yield of 9,560 kilograms. Is it plus 32? Okay. Is that right? Plus 32? Yeah. So it works out. The farmer's total cost for producing the wheat is 1,300 per hectare. Or 1,000, so it costs him this much to do it. He can sell the wheat for 160 euros per ton. Now, what is a ton? Anybody know? 1,000 kilos. Okay. So if we produce 1,000 kilos, how much is 9,560 in tons? 9.56. Just divided by 1,000. So we produce 9.56 tons. Okay. So he can sell the wheat for 160 per ton. He can also get 75 euro per hectare on leftover straw. If he achieves the maximum amount of wheat, what is his profit per hectare? We produce 9.56 tons per hectare. So the 9.56 gets multiplied by what number? 160. What happens when we multiply by 160? What do we get? 1529. 60, right? How much extra money do we get for selling off the straw? Where's the straw we sold off? 75 euro for extra straw. And then what we're going to take away? We're going to take our 1,300 away. And how much did we make in total? I have it there in the notes. Anybody tell me? I put 78 euro instead of 75. That was really smart of me. Okay, so 1529.60. I'm hoping my 5 just looked like an 8. What do we get? 304.60. Yeah. Okay. So guys, questions 9, 6, 5, 9, 6 and 1, was it? 5, 6, 9 and 1. Okay.